Every day, the future's getting closer.
Welcome to Master the NEC, where we talk about the National Electrical Code and all things electrically related. My name is Paul Abernathy, your host, and welcome to today's podcast. Well, hello everybody. Welcome to Master the NEC, a series where we talk about the National Electrical Code and all things electrically related. My name is Paul Abernathy, your host as always. Welcome to our podcast. On today's podcast, we are going to talk equipment grounding conductors, 250.122. We'll also maybe dabble. I'll give you a 30,000 foot view of what's going on in the 2020 cycle when it comes to the table 250.122 and the concepts of what's going on. I'm really not going to dabble in a lot because we still have a public comment stage to go through, and there's liable to be radical changes to that, or it's liable to result back into the way it is in the 2017 code, which is purely the table that we're all familiar with. Unfortunate with that, if it does result back, then it gets rid of some things that we worked really hard to get rid of, like the requirement to increase the size when you increase the conductors and things like that. So hopefully we don't lose all that work, but that's what we're going to have the public comment meetings for in San Diego in a couple months, I guess, and we'll hash all that stuff out. And we'll also look at some of the fallacies that we ran into when we voted to kind of change the way 250.122 looks and how it functions. And there's some of the things that, obviously, a lot of that didn't get thought out pretty well going into it. Not to take away the efforts of the individuals who really worked on that. Certainly not to say anything negative about that. It's just that I guess we didn't look at all the potential aspects of what was going on in this new sizing scheme or sizing structure, if you will. So to go in and knock it out of the way, what happened in the 2020, there was a group that worked on changing and going away from 250.122 and sizing the equipment grounded conductor based on the overcurrent protected device. What they wanted to do was use the sizing parameters that are listed in UL 1569 for MC cable and 1277 for tray cable, which kind of gave guidance, which really, to be honest with you, it mirrored what 250.122 was anyway. So as a manufacturer of cable, we manufacture to the minimum requirements of the standard, and it usually mirrors 250.122. So either which one was leading on the other, that's what we used. Now, what happened was it was presented that if you can parallel phase conductors with no issues, if you can parallel grounded conductors, which we do all the time, obviously remembering all the rules of paralleling that we have to keep aware of in 310. If you meet all those type of things, and when I say that, I mean 1/0 and larger applications for paralleling. If you say that, then many people said, well, why can't you parallel the equipment grounding conductor? And so there was two sides to that argument. One side of the argument is that currently the way the code's read is that you're sizing that equipment grounding conductor full size in all raceways. So if you parallel it out, it'd be full size in all raceways. And there are allowances in the code where it says that, it doesn't have to be larger than the circuit conductors. However, there is a caveat in there where an engineering during a design could ask or request or demand that the equipment grounding conductor be larger. And that was their prerogative. Whether it's based on looking at the clearing cycles of an overcurrent device for use for specific application, whatever it was, because ICEA puts out these documents, as well as the manufacturers of circuit breakers and things like that, will put out these documents that say how many cycles of clearing time versus the size of the conductor, and what is the short circuit current rating in amperes that a conductor can handle, based on the clearing time point of that circuit breaker or fuse, and all these type of things all went together at some point to help create 250.122 through the years. Now, I'm not a NEC historian by any means, so at some point things get into the code because you hope that it has some foundation in research and something like that. Although from my first-hand experience, a lot of times There are certain people that on code panels that can get things in that others can't. And even if you have tons of research and data, you can't get it in there for the life of you. But some people can barely present anything and it gets in there. So go figure. Not saying it's corrupt. I certainly would never say that. I'm a big advocate for the process, and I think we do. It's a benefit to the industry. But again, there are certain individuals that people take things they say for gospel, and there are other people that are very knowledgeable, but some reason they don't want to listen to what they have to say. Maybe that's personality conflicts. Who knows? It's like any little clique group. If you're not in the clique, you're not going to have very good success at getting what you want done, even if it's good for the code. Unfortunately, it's sad, but it is the truth, and I still love the process. And to me, it's being the fact that I had been involved in the NFPA process as well as the ICC process and all that. I take the NFPA process over the ICC process any freaking day of the week. And don't get me started on the I codes, man. I've been involved in those when I was at NEMA, and I think that is a farce, but that's for a different podcast. Yes, we need them. I get it. Yes, I'm thankful for those that are dedicated to it. I do. But those are weird, because if you just stay up long enough into the night and your voting thing comes up and you outlasted everybody else that left, you can lobby the room and get something passed that normally you might not if everybody was there at 8 o'clock voting versus those that are there at 12 o'clock or 1 o'clock in the morning. If the sessions are getting behind, there's less people in the room that could be of opposition. I'm just saying. I've seen it happen. All right. Not so much the case in NFPA. Again, the NFPA is kind of driven on all of you submitting public inputs and public comments to those first draft revisions that come out of the public input stage. So you have an input. You truly do. And you do with the iCodes as well, but the NFPA, then you have people sitting around the table and we get to look and say, well, thumbs up, thumbs down to your public input or whatnot. Or maybe we massage it or change it in some way or add to it, or maybe it gives us an epiphany during the meeting and we create something that can maybe benefit the code or not. Unfortunately, sometimes personal agendas do weigh heavy. And sometimes people get accused of personal agendas when they're only trying to make the code better. It just happens. So anyway, so let's talk equipment grounding conductor. So the 2020 cycle, it was presented to base the equipment grounding conductor. This was proposed to base the equipment grounding conductor based on the concepts of a new table that was derived from the way it's done in UL 1569, which is for MC cable, and tray cable, which was UL 1277. Using those guidelines, which incidentally were pretty much paralleling 250.122 anyway, everything seemed to work out fairly well and matched up until you got to certain sizes, and then it kind of really, benefited you to use the new format versus the old format. And of course, so everything seemed adequate, and then the snag came up. And the snag came up was, how do you deal with the aspects of motors and maybe instantaneous trip, where you have the potential for 800% up to 1700%, and how to deal with that, things like that kind of creeped in. So motors created a problem with that application. So, and we also realized that during the public, the first draft meetings that were in Hilton Head, that we really didn't have a provision for applications where you needed to have a 12.5% added into it, where you could have potentially an equipment grounding conductor that would be undersized based on this new scheme. So 12.5% was added to it, and you kind of thought that might have solved it. The problem with it was that I don't think at that point any modeling had been done. It was just based on where did we get 250.122 from, which is probably legacy for years of research. And, the argument was brought up that, well, again, if you can parallel the phase conductors, you can parallel the grounded conductors, and one not larger, and you could parallel, why couldn't you parallel equipment grounded conductors? Well, there's two camps here. The one camp there says, look, we've always had full size in every raceway. When running in parallel. If there's a fault in any one given raceway, then the amount of current that fault will generate on that return path facilitated the need for the full size, because you still had to clear whatever that overcurrent device was that you were basing the size of your equipment grounded conductors on. Obviously, it could be large, 1600 amps, 1200 amps, and you had to run parallels. Well, that was the conventional theory there. And we've done it for years, and it made sense to everybody. Then what they started saying was, well, again, if you can parallel the grounded conductor, which could carry fault current, if you can do the phase conductors and parallel them, and why couldn't you parallel the equipment grounded conductor? Well, many people also realize that if I'm running full size and you parallel those, you add up those circular mills, then you have got literally a huge equipment grounded conductor. And they argued that that was just totally unnecessary. And so you had the two camps, the camps that believe that you need full size because at any given time you have to rely on that equipment grounded conductor to potentially clear the overcurrent device. And there's others that says based on how it works, then that you're getting your parallel, but you're not having to have the full size in every raceway. You can base it on a paralleling of the equipment ground, and their belief that if you look at that individual equipment grounded conductor, based on its size, using formulas from ICEA, whether it's copper or aluminum, and looking at it and saying, well, look, we know, for example, a 10 gauge can handle 4,300 amps of current on a 1 cycle or a 0.0167, okay, for 1 cycle for its opening cycle. Okay, well, that's quite a lot, 4,300 amps. So we have to look at what that short circuit current rating is in amps, and look at all that in order to be able to facilitate that and understand it. So we were kind of relying on the manufacturers of the circuit breakers because at the end of the day, that's what we're trying to do, right? We're trying to clear an overcurrent device. And I don't think at that point when I say we, I'm a member of that panel. So I don't think collectively anybody that was developing that really took into account what the manufacturers of the circuit breakers and fuses had to say. And so what happened is they, it looked like it was very positive, and everybody, we kind of massaged it during the meetings, and it looked like it went forward. And then, of course, at that point, some questions arose. And it was circulating around the motors, and it was circulating on whether or not reducing the size of equipment grounded conductor for each of the leg in a multiple parallel sets would actually clear a larger overcurrent device. So whatever the cycle was for a 1200 amp overcurrent device, for example, and you parallel that equipment grounded conductor based on whatever size it was, based on the cycle clearing time of that overcurrent device, what was how many amperes of short circuit current could it all handle, and could that conductor actually handle that? Now, we can model that when we look at tables and the graphs, but we really have to walk hand in hand with the manufacturers of circuit breakers. So this was a great example where it might be a move in a good direction, although, again, I like the concept of sizing it based on the overcurrent device, but that gave us some opinion that the overcurrent device manufacturers had a role in this aspect of it, but they have to work hand in hand with the wire manufacturers because the wire manufacturers produced a wire to their standards, and the copper or the aluminum. And they work with the ICEA and everything in order to come up with these curves and these graphs and everything to see whether or not it's adequate. Like I said, a conductor withstand rating, when you look at one of the charts, for example, a 10 AWG copper is suitable for not more than 4,300 amps if the overcurrent device will open the faulted current at 1 cycle. Okay, that's 0.0167 seconds. If that's the case, then that 10 can actually handle all the way up to that level of conductor withstand rating and not have a problem. Okay, and it's a very quick amount of time, and that breaker is going to open, and everything's good. So that's the things that we have to look at because there could be problems with that. Now, the 10, for example, that we talked about, a 10 AWG copper should not be used where the available fault current exceeds approximately 3,000, for example, if it goes up to a 2 cycle. So that's where we get those values from, and there are published tables that show you that. And you just simply go through and find out what the clearing cycle is of the overcurrent device, and then you can kind of look at that and tell what size conductor you're going to need. It comes with the formula, which has created the graph, but you can just use the graphs. They're pretty simple to do. And that's, they kind of mirror up. And so I think what happened is and I'll tell you the other reason why we did it here in a second, or why it was done that way. The concept was, I don't think we involved the manufacturers of the overcurrent devices in any actual testing. The one is because testing costs money, and these testing associations are just eager to do the testing as long as they're going to get paid. No disrespect to UL or ETL or any of them, but they have programs where they're now for profit, so they love to do testing, but they're not going to do it on their own. Somebody has to fund it. So if you're willing to do it, then they can come up with some data. Now, there was an individual that was at the first draft who has a company that offered to do all the modeling for this, which can be based on looking at tables and existing data. He offered to do it for free. Now, I'm assuming nobody took this gentleman up on his offer, because I'm not here to volunteer for the committee, but somebody could have taken that gentleman up on his offer and at least could have given an attempt to do some modeling. And for all I know, they might have. And when I get to the meetings in San Diego, this gentleman might have already done that. And they are doing a task group right now to look at all these potential issues that were encountered. And so hopefully they're going to solve that. And now, again, the concept was basing it on UL 1569 and UL 1277. This is the new table that was being proposed for the 2020 NEC for sizing equipment grounding conductors. And it was going to allow a paralleling application, and which is not now allowed. In other words, they're full-sized with every raceway and every set of conductors that are run in a parallel set. That's the traditional. That's what we've done to this point. So the concept was to move a little bit away from that. And, during the meeting, I'm sure we're going to hear a bunch of different resolutions to that. But it was all really based on pulling it from these tables. And these tables created conductors, cable assemblies, that the equipment grounding conductor was sized based on that single cable being used with an overcurrent device. And so it was a specific size equipment grounding conductor. So when you went to parallel MC cables or tray cables, you ultimately had an equipment grounding conductor that was too small. And it was too small to be used in a parallel application, but it was okay. We're using a single cable application. Well, a lot of people want to parallel MCs. A lot of people, it's a simple installation. A lot of people want to parallel tray cables and cable trays and things like that. So they came up with an allowance to say, look, we'll let you use, and this is in 250.122F, we'll say F2, for example, it will let you run the cable in parallel with the existing equipment grounding conductor, which is perfectly sized for a single cable, but it's undersized when you're running it in a parallel application. But we'll let you use it as long as you run a adequately full-sized equipment grounding conductor in that same tray, and at the end you connect it with all of the equipment grounding conductors that are in the cable assemblies together, and that they start and end in the same panels as all the conductors end and start at. And that's perfectly fine. So that was the concept with the change. And so what it did allow you to do was use existing standard off-the-shelf cable assemblies, but you had to run a full-sized equipment grounding conductor. And you only had to add one, but it was in there, and it had to be run with those circuits all the way back to origin and to destination. And then they were connected together physically or on the same bus, all met the same application. And that was an effort to say, well, we'll let you do that, and you can use the off-the-shelf stuff and run it in a parallel application. But the movement was to get rid of that and say, well, wait a minute. Maybe that equipment grounding conductor that's in those cables in parallel, which collectively add up to a certain circular mill size, no different than the grounding conductor does or the phase conductors do, why can't it be in parallel? And where evidence do we have that 250.122's origin is any better, or maybe we're being grossly oversizing of these applications because we're not having issues with it? And some people in that camp will say, yeah, we're not having issues because it works. And then the other ones say, well, maybe they're oversizing, it's not necessary. We can parallel everything else. And that's where you have those two camps. Like I said, well, one said, yeah, but if it's 1200 amp or 1600 amps and you parallel it out and it's full size in each raceway, then that equipment grounding conductor in a fault in that raceway has got to clear that singular overcurrent device itself, which could be 1200, 1600 amps, or whatever it might be, 2000 amps, 2500, 3000, whatever it would be. And could it do it? That was the thing. If you do it full-sized in every raceway, then they felt more comfortable that it would actually clear, and that's the whole intent, right? I think a lot of this was done without the manufacturers of circuit breakers, and there's very intelligent engineers that help design these devices that can look at these aspects of the amount of current, short circuit current that's going to be available for a certain period of time based on the rating of their device. They have an enormous amount of curve data that can actually give you this information, and they needed to do an extensive study, and I don't know that it's been done, but I know that it was a concern because the meetings that I had back with NEMA, it was brought up, and the manufacturers are in those meetings and they had concerns, so they were probably looking at it as well. So when we get to the meeting in San Diego, we're either going to have data for this or it's going to be dead in the water. The cable manufacturers like the concept because then we don't have to make a specialty cable for it. Then it's perfectly fine. We're manufacturers of cable neither here nor there with it because we're going to sell the cable either way. And the cable is going to be designed for use as a singular use. If you want to use it in parallel, we're more than happy to make you a cable with a oversized, a larger equipment grounding conductor if you want. We're more than happy to do that. It does cost more because it's not a stock product. But there is an alternative, and 25122F2 gave you an alternative in those applications. So we did meet that. And so I don't know what's going to happen for the 2020, but it looks like at this point, unless we can solve the issues with the instantaneous trip aspect of motors and sizing it based on the new concept of the table, other things have probably surfaced when it comes to NMB and aspects of those type of products. All of those type of things, the larger sizes that you deal with, all those things might be something that has to be looked at. And so I don't want to go into much more detail than that, but that's where we were. We were all really going to base it on the same concepts that were found in the UL standards for cable assemblies. And that would allow the manufacturers to be able to sell a cable, the equipment grounding conductor. If you ran multiple cables together, then you could use cumulatively these equipment grounding conductors, and in a sense, they are still connected in parallel. So that was the other argument. People said, well, even if it has a fault in one, they're still connected in parallel, although you have to remember that if the fault happens in one, it's not necessarily going to divide into the parallel paths because it's got to come back on the one. It might sort its way through all paths, but again, of course, the impedance being what it is, it's the division of it could be a little sketchy, and some people argued. So we're going to have to work through it. I guess they're going to figure it out, and I wasn't a part of that committee. I was offered to be. I just had too much other stuff on my plate to be involved in that. But I am very much anxious to see what they come up with. I am definitely anxious to see what they come up with. So dealing with the 250.122 aspect, that's just kind of giving you the overall of what's going on with it as far as the 2020 cycle. The 250.122, one of the things that a lot of times what we deal with here is understanding the concepts of one phrase in there where it says, in no case shall they be required to be larger than the circuit conductor supplying the equipment. That statement in there is just simply to remind you that it's not going to be necessary. Follow the table. It's no sense, for example, if I run 6 sets of something, and I don't have to take all of those conductors, come up with a certain circular mill, let's say, of all of those conductors or of all those sets, and turn around and say, okay, well, my equipment ground doesn't have to be larger than that. Well, no duh, because that could be a rather large value for if you're running it. Because it says it's in no case shall they be required to be larger than the circuit conductor supplying the equipment. Well, if I have 6 sets or 8 sets or 10 sets supplying the equipment, and it says no larger than the circuit conductor supplying the equipment, well, all of them are supplying the equipment. So I would take whatever the circular mill is of one of the phase conductor times how many of the number there are, and it's just saying, well, your equipment grounding conductor does not have to be smaller than that, okay? It doesn't have to be larger than that. Well, of course it wouldn't. So easiest thing to do is just simply go to 250.122 and follow what it says. And right now you put the full size in each raceway, and you leave it at that. So we'll see where that actually goes. But that's the general rules for 250.122 when it comes to that. One of the other efforts in the and also, you see this quite frequently. The equipment grounding conductor shall be permitted to be sectioned within a multi-conductor cable, provided the combinated circular mill area complies. So that is those cables where you see the 3 individual equipment grounding conductors being run, and they kind of sit in the interstices of the cable assembly. That is allowed to be done as long as the combined circular mill of each of them does combine to meet the requirements in table 250.122 as far as size. And when they get to the end, they come together. And so they're actually, in a raw explanation, they are being run in parallel inside the single cable assembly. So that obviously that's sectioned, and that's allowed to be done in multi-conductor cable assemblies. The one thing that we were looking to get rid of in the 2020 was the B item, which is increase in size. So where the ungrounded conductors are increased in size from the minimum size that is sufficient ampacity, whatever the minimum was needed to actually run the load for the intended installation, in a wire type equipment grounding conductor where installed shall be increased in size proportional according to the circular mill areas of the ungrounded conductor. So what I needed to run for the circuit and what I proposed to run for the circuit, then I do a little bit of a calculation there, and that gives me a value, and I take the equipment grounded conductor that I was going to run and I do it times that value, and now that's my new equipment grounded conductor, and I increase it in size proportional, okay, to what the new ungrounded conductors are that I'm running. And I think we have a video or an episode that explains that. But there was really trying to remove that because it really got into an aspect of what are we talking about? Are we just increasing it for an engineer designed it to do that? Or was it necessary? Was it for a voltage drop, which is not a requirement of the NEC except for things like fire pumps and some other aspects for special provision. Other than that, is it just a good design thing? So we're looking to get rid of that in the aspect of it. So I don't know how that's going to work out in the 2020 edition, but that was one of the things that many people argued that was unnecessary to do it that way. It's a pretty simple math process to do it, but people argue that it wasn't necessary. You'll just have to see how that turns out. Item C, dealing with multiple circuits. This is one where I do get a lot of questions from people from time to time where they have a raceway and they have multiple circuits that are actually in the same raceway or in a cable or in a cable tray. And they want to size the equipment grounding conductor, and they think they need multiple equipment grounding conductors. Well, no, you can size it to the largest overcurrent devices protecting the conductors that are in that cable, that raceway, or that cable tray. If it's a 60 amp, a 20 amp, a 30 amp, and a 40 amp in there, for example, and if I size that equipment grounding conductor based on the 60 amp, then that's all that's necessary because obviously it is larger than the one that we required for the others. So, or at least equivalent. So that's the concept there. And so it just kind of rolled into that where people say, now once you get to a certain location, and this gets done for multiple circuits in a raceway, and it comes to a junction box, and now those circuits are going to branch out, then it's different because the equipment grounded conductor that you would run from that point with that circuit that branches out is going to be based on what that circuit is that you're running. Okay, so if it branches out and that circuit is a 40 amp circuit, then the equipment grounded conductor would be based on a 40 or 30 or whatever it is that's protecting that circuit from that point on. But if they're all running the same raceway, well, at that point, they're not all in the same raceway. They're now branching off, going to wherever their respective loads are. Okay, so that's a concept, and there's nothing that says you don't splice all the equipment grounds of different sizes together. I have heard that for years where people say you can't splice 12s with 10s and whatnot, and the code makes it very clear you do, and that's not an issue. The only other thing with multiple circuits, for example, where I'm going to have multiple circuits and I'm going to share, if you will, a single equipment grounded conductor, is that equipment grounded conductors installed when they're in cable trays have to meet the minimum requirements of 392.10b1c. Okay? All right. And for those that aren't familiar with that, then we do get a lot of people that ask me this question also. Can I run individual conductors inside of a cable tray? And the answer is yes. But it has to be in an industrial establishment. How many commercial buildings have you been in that you've seen them run individual conductors in a cable tray and nobody blinks an eye, nobody has a problem with it? But the reality is 392.10b is talking about industrial establishments. The permitted use of the different types of wiring methods that are in cable trays are governed under 392.10a, which sends you to a table which lists everything. And you'll notice that it doesn't list individual conductors in that table at all. It does list tray cable. It does list MC, NM, SE, all these different types of wiring methods that are permitted in there. But individual conductors aren't really wiring methods. Okay, they're conductors. So a cable tray is not a wiring method. It's a supporting structure. Okay, it's not a raceway. It's a supporting mechanism. And I can put inside of the industrial establishment, I can use any of the wiring methods that are in 392.10a, the table. They're permitted to be in there. Okay, not a problem. But in industrial establishments only, where there are conditions of maintenance supervision to ensure that the qualified person is there to maintain the installations, then I'm able to run any of the aspects of 392.10b1 and b2, which is single conductor cables, and of course single and multi-conductor medium voltage cables. We don't deal in medium voltage cables, so I don't get involved in those. Okay, so we're talking single conductors. Now, the reference that we just gave in 392.10b1c just reminds us that I can have single conductors used as equipment grounding conductors, shall be insulated, covered, or bare, and they shall be 4 AWG and larger. Now, the reason that's significant is because most of the allowances for individual conductors to be run inside of a cable tray, it's going to be focused on 1/0 AWG and larger in those aspects of it. And so this is an allowance where the equipment grounding conductor does not have to be 1/0 and larger. It can be 4 and larger. And of course, it could be insulated, covered, or bare. Of course, that's just remembering if it's insulated, then it's going to be green. If it's bare, it's going to be, guess what? Bare. All right, so that's kind of what it's just reminding you of the size when it talks about a cable tray application. Okay, so that's all we're talking about with that. All right, what we get into now is what came up with, and this is existing code. So we're talking 2017 right now. So what we're going to do is, in our mind, we're putting away the concepts of what I was telling you about the 2020 because we don't even know if that's going to make it yet. We don't even know what's going to go on with that. So we have to work on what we're dealing with in the 2017 code. And so we kind of determined we have to increase the size if necessary, if we increase the ungrounded conductor for any reason from what it would normally be sized at. If we increase any of those ungrounded conductors, then we have to also proportionally increase the equipment grounded conductor if it's of the wire type. Of course, if you're using a metal raceway, 250.118 allows that to be an equipment grounded conductor, and there's no provision to increase that for any reason. A raceway is what it is. If it's listed in that of those options, then you can do it, EMT, whatever. So this case, the increase in size is only really dealing with the wire type. Of course, I'm sure all of you know that. Now, D, again, motor circuits, which created the biggest challenge. Currently, the way it reads today, the way it reads in the normal 250.122, it works in a sense of we know that we got to run full size in each raceway anyway, and so we're sizing based on the device, and we're going to use the short circuit ground fault device to do this as well, which is going to be larger, which is ultimately going to push into a larger equipment grounded conductor to make up for that aspect. With the change of the way the code was being proposed, we kind of maybe lose some of that. So I'm sure that's being worked on, and I'm sure they're giving that consideration. But let's focus on the 2017. So when you're dealing with motor circuits, equipment grounded conductors for motor circuits shall be sized in accordance with D1 or D2. So there's an or, so either one. And D1 says, okay, look, the equipment grounded conductor shall not be smaller than determined in 251.22a based on the rating of the branch circuit, short circuit, and ground fault protective device. So if we have a requirement in 430.52 and it is at 250% or it's whatever the percentage is, that would require us to actually pick our equipment grounded conductor from 250.122 based on whatever that device would be, okay, for the short circuit and ground fault protection, which ultimately is going to result in a larger equipment grounded conductor. And in most people's arguments, that's going to result in a conductor that can handle a lot more short circuit current that could be imposed on it. So it kind of fixed itself in that. So we dealt with that. Again, remembering that you do have your general rule says that the equipment grounded conductor never has to be larger than the circuit conductors. Okay. Also remembering that is true, but your engineer has the ability to size it based on whatever they do their calculations. Again, code is a minimum standard. Okay. You can probably argue that until you're blue in the face, but if your engineer calls for it to be oversized, I give a great example. I see engineers all the time call a 3/0 copper to a ground rod. And they will insist until they're blue in the face that that's what it needs when the code says it only needs a 6. I'm not going to argue with their design. That's their design. They have their prerogative. They have their reasons. They have their liability. They have their stamp. I'm going to do what they tell me to do. I realize that it's a pain in the butt to make that connection to a ground rod with that size because there's no real clamp that does that. So I'm going to have to do a CAD well or something. But it is what it is. And incidentally, as a contractor, I never owned a CAD well. I always had to borrow one from somebody. And I had a guy who had one, so I figured, hey, it was easy to borrow his. And I ended up using it more than he did. But he wouldn't sell it to me because I was cheap. I wanted it cheap. And they're not that expensive. But, I'm not going to go into my cheapness. All right, so the next thing was D2, which is dealing with those instantaneous trip circuit breakers and those motor short circuit protectors. Now, the code says here, where the overcurrent device is an instantaneous trip circuit breaker or a motor or an MSCP or a motor short circuit protector, it says the equipment grounded conductor shall be sized not smaller than that given in 250.122A using the maximum permitted rating of a dual element time delay fuse selected for branch circuit, short circuit, and ground fault protection in accordance with 430.52C1 exception number 1. Okay? And of course, that gets into dealing with the table 450.52, the exception, again, where the branch circuit, short circuit, and ground fault protection device that is provided in 430.52 doesn't correspond. Again, we go into 240.6 for that sizing to pick the one if it doesn't correspond. Then at that point, I can go to a higher size rating that does not correspond to the next standard rating. It shall be permitted. So you read that, and of course then there's exception number 2, blah, 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 dealing with fuses and whatnot. So that's all it's really dealing with there is saying, look, at the end of the day, whatever I ultimately have to choose the size of the ground fault short circuit protection, that's what I'm going to size my equipment grounded conductor to. Okay, so it's really no different than size it to the circuit breaker. You just let this guidance steer you when it comes to sizing it, and you're doing this all based on, again, the 430.52. And again, it could result in an excessively large device when you realize that an instantaneous trip breaker is 800%, okay, of the full load current. So that's just one of those things to keep in mind, okay? So anyway, that's kind of how that goes when it comes to that. So let's kind of maneuver our way back to 250.122. If you bear with me here, while I tend to just run with these things, and I'm doing an electronic version, so I gotta get forward here to where I'm at. Okay. All right, so that's dealing with what you have to deal with the instantaneous and exception number 1 based on that. And the next one is E, which is dealing with flexible cord and fixture wire. I usually don't spend that much time in this one, but I just figured we'll just read it. Might as well cover the whole gamut here in 250.122. It says the equipment grounded conductor in a flexible cord. Flexible cords, incidentally, are covered in Article 400. Flexible equipment grounded conductor in a flexible cord with a larger circuit conductor than 10 or smaller. With the largest circuit conductor 10 or smaller, and the equipment grounded conductor used with fixture wires of any size in accordance with 240.5 shall not be smaller than an 18 AWG copper. Okay, so again, 10 and smaller, and the equipment grounded conductor that's used with fixture wire of any size in accordance with 240.5 can't be smaller than 18 AWG copper. And shall not be smaller than the circuit conductors. Okay. It says the equipment grounded conductor in a flexible cord with a circuit conductors larger than 10 AWG shall be sized in accordance with table 250.122. So 10 and larger or larger than 10, you're going to go and use the actual table. 10 and smaller or with fixture wire of any size, you're going to let 240.4 be your guide, and then of course they're not to be smaller than 18 AWG, okay? Or they're not smaller than the actual circuit conductors to which you run, okay? 18 gauge conductors, 16 gauge conductor, whatever you're running. All right. F, parallel, conductors in parallel. Again, this is just a reminder for circuits in 5. It actually was, like I said, it was new, if you will, the way it was constructed for the 2017 code. So you'll see these ends in the column to the left of it, which lets you know this is new information. And of course, the grayed out information in F is just some rewording in order to incorporate the two new options here, 1 or 2, which one applies. And it says conductors in parallel. It says for circuits of parallel conductors as permitted in 310.10h, and of course you remember 310.10h is going to give us all those parameters of the conductor length, installation type, conductive material per set, individual conductor in a set. Like A, B, and C. A could be copper, B could be aluminum, C could be copper. Again, as long as all of the B's are the same and everything that way, the links are the same. Everything is done properly in accordance with 310.10h, then you can parallel and follow all those rules. Okay, so it says that you can, as long as you follow those rules, it says the equipment grounded conductor shall be installed in accordance with 1 or 2. Now, 1 or 2 are new to the 2017 code. And number 1 says conductors installed in raceways, auxiliary gutters, or cable trays. There's a B in this application. So look at A first. Now A says, okay, remember what I'm doing now. I'm running parallel conductors, and I'm trying to deal with the equipment grounded conductor here. Now it says A single raceway or cable tray. Single, only one. It says if the conductors are installed in parallel, okay, so I might have multiple sets that are installed in the same raceway or cable tray. Again, we're dealing with the singular one now. It allows me to run a single wire type conductor shall be permitted. It's not required, but I can run a single wire type conductor as the equipment grounded conductor. And it says this wire type equipment grounded conductor shall be sized in accordance with 250.122. We already kind of established that. Based on the overcurrent protected device for the feeder or branch circuit. Okay? So I'm basing it no different than we've done before, and I'm going to base it on 250.122 based on the overcurrent protected device for the feeder or branch circuit. Now, it says wire type equipment grounded conductors installed in cable trays shall meet the minimum requirements of 392.10b1c, which we saw that earlier is no smaller than 4 gauge. It might be larger, but not to be smaller than a 4 gauge. Okay. It also says that metal raceways and auxiliary gutters in accordance with 250.118, and that means when we see 250.118 means that they qualify as an equipment grounding conductor. So those that are an equipment grounding conductor or cable trays complying with 392.60b, okay, which happens to deal with, in case you weren't aware of it, that deals with steel or aluminum cable trays. So if I have a steel or aluminum cable tray, it shall be permitted to be used as an equipment grounding conductor, provided it meets all the following requirements. And there's 4 different requirements that it has to meet in order to qualify. So that's where I'm actually using a steel or aluminum cable tray as my equipment grounding conductor, kind of like I use the raceway as my equipment grounding conductor. And that it can be done. And that's where you sometimes see cables that go into it that maybe won't have an equipment grounding conductor with it because it's utilizing the actual cable tray system. Now, to do that, number 1, the cable tray sections and fittings have to be identified as an equipment grounding conductor. So I'm looking for some kind of identification, some kind of mark, some kind of little symbol. Also, it says the minimum cross-sectional area of the cable tray conforms to the requirements of 392.60a. Okay, and in that you have some requirements, and if you look at it, that's a little table there based on the size of the circuit breaker or whatnot. It'll give you some square inch values for steel or aluminum to make sure it meets that. You can get that from the manufacturers of those trays to see if that qualifies. And of course, if it has that label, then they probably already looked at that. But again, it is dependent on the size of the circuit breaker or fuses or whatever that's protecting it. So it does change in size. So you have to verify all that. Assuming you have, and we move on, it says all cable tray sections and fittings are legibly and durably marked to show the cross-sectional area of metal in channel cable trays or cable trays of one-piece construction, and the total cross-sectional area of both the side rails for ladder or trough cable trays. Again, you have to have this data. It's all got to be there in order to be able to use it. So if you're going to use the cable tray as an equipment grounded conductor, you simply got to follow down the list and make sure the tray, you would contact your cable tray manufacturer prior to ordering it and make sure that it meets all these requirements. And hopefully they know this, but don't take anything for granted. If you're planning on using the cable tray as your equipment grounded conductor in your installation, I would take this area of the code, I would cut this out, I would paste this in an email to that manufacturer, and I'd say, please tell me you meet all these requirements. And hopefully the engineer will look at all that, but there's it. And then you get the fourth one. The fourth one says cable tray sections, fittings, and connected raceways are bonded in accordance with 250.96 using bolted mechanical connections or bonding jumpers that are sized and installed in accordance with 250.102. And of course, 250.102 is our sizing for bonding jumpers. And again, depending on the aspect of whether these conductors, where they originate, and the sizes of those, then we're going to size our bonding jumpers based on 250.102, and subsequently it's going to send you to the table in order to be able to do that. Okay, so you do all that if you have different components that you're going to bond them together. Okay, all right, so that's what you find. If you can meet all of those requirements, then you can use the cable tray as your equipment grounded conductor. What thing I would probably say to most people is never ever assume that that's what the case is going to be. Okay, just because you see the cable tray and you think, well, hey, I've got it made now, I don't need to run an equipment grounded conductor because I'm going to use this tray. Be careful. Okay, don't assume anything when it comes to that. But that's what it's talking about when it makes a reference in 250.122F1 at the end of the first item A, when it talks about cable trays complying with 392.60B. That's for those that can comply and be an equipment grounded conductor, and you got to meet all those caveats to do so. Now, conductors installed in raceways, auxiliary gutters, or cable trays, you also have a B, multiple raceways. Okay, it says if conductors are installed in parallel in multiple raceways, the wire type equipment grounded conductor, where they're used, again, because it's a metal raceway, you don't have to use a wire type equipment grounded conductor because the raceways might qualify as an equipment grounded conductor, and then some might not. Okay, so where they're required or where they're actually used, obviously we would use them in a PVC application. There's a no-brainer, right? Okay. It says where used shall be installed in parallel in each raceway. The equipment grounded conductor installed in each raceway shall be sized in compliance with 250.122 based on the overcurrent protective device for the feeder or branch circuit. Now, it goes on to say, again, metal raceways or auxiliary gutters, and remember, auxiliary gutters are usually ancillary space to a piece of equipment in order for bending and other things like that. Not necessarily, auxiliary gutters not necessarily equating to what we call a wireway. It usually is an accessory component. But it says metal raceways or auxiliary gutters in accordance with 250.118, which is telling you that they are equipment grounded conductors and they meet those rules. It says, or the cable tray is complying with 392.60B, which we just talked about, means that are actually meet all those qualifying components to be considered an equipment grounded conductor, then they're permitted to be used as an equipment grounded conductor. Okay, so everything's covered in there. But again, you're going to put full size, you're going to follow the rules of 250.122, and you're going to put a full size in each raceway. And that's the traditional way we've always done it. All right. So then you get to what's called multi-conductor cables. And this is what's kind of trying to help people be able to use standardized cable assemblies. Okay? Because the equipment grounded conductor in those standard cables is only sized for that cable to be used on a single overcurrent device for that single cable. But many people will parallel them, like we said. Well, then that results in an equipment grounded conductor that ultimately can be too small. Okay? So here's what the rule is. You have an A, B, C, D here. And it says, let's look at each one of them. A says, if multi-conductor cables, and again, MC cable, tray cable, those are multi-conductor cables, are installed in parallel, the equipment grounding conductors in each cable shall be connected in parallel. Okay, so that's a no-brainer. So again, the installation of a parallel requirements means that they start and they end together. They're truly being run as a parallel. They're not connected at one end and then open at the other end. They have to be connected in parallel for this multi-cover to do this. Okay, so that's the first caveat. B, it says, if the multi-conductor cable are installed in parallel in the same raceway, auxiliary gutter, or cable tray. Okay, so their multi-conductor cables are installed in the same raceway, gutter, or cable tray. You're allowed to have a single equipment grounding conductor that is sized in accordance with 250.122, which we've always done, and it shall be permitted in combination with the equipment grounding conductors provided within the multi-conductor cables, and they shall all be connected together. So like we said, if I have a cable tray and I've got multiple MC cables and they have the equipment grounding conductor in there that's maybe undersized if we're running it in parallel to a larger overcurrent device, but they'd be perfectly fine based on their standard to a single overcurrent device for that one cable assembly, then from point where they begin and end, as long as the equipment grounding conductors are connected together and they're connected with that single equipment grounding conductor that you're allowed to be run, and they all connect together at the same location, which means they're going to have to be in the same panel where they originate, in the same panel where they terminate, ultimately, in order to be run like they're all in parallel. Remember, tying everything together is the concept of parallel. And so you do get the benefit of that larger. Now, many people argued and said, well, that's the genesis of why we argued with the new change in 2020. If you're allowed to do this, what did you base that on? Because I'm going to let you run one single one, but in each raceway, I've got a conductor that's now sized for that raceway, okay, or for that actual cable assembly. And if there's a fault in there, will that be too small to clear the overcurrent device? But yet, we allow you to do it this way and run one larger one, and so we assume that all of this fault current is going to evenly divide, even though these are too small. So that was the genesis, I guess, of the people that are arguing for the change in the 2020 to say, wait a minute, if y'all pass this and y'all allowed to run one single one and then have the other ones that are technically smaller in each one of the cable assemblies, but it's okay to run the single one and you assume that that's going to do everything, then why wouldn't you let me parallel it out? And so that was kind of their argument. And I don't want to get too more deeper into that, but you're allowed to do this in the 2017 code, and it can save you from having to get specialized MC cable or tray cable or whatever you're going to run inside the cable the cable tray or whatnot. Okay, it would allow you to, but you still have to run that single full-sized equipment grounding conductor in there. Okay, and then you connect them all together like a parallel application in the end. Okay. Ironic that is a parallel application, but in that case you don't have to follow all the rules in 310.10h because obviously that full side one's going to be larger than the other ones that are inside the cable assembly, but the concept of paralleling is all still there, so we get that. All right, then it goes on to C, and it says, now, the equipment grounding conductor installed in a cable tray shall meet the minimum requirements of 392.10b1c, so that is the 4 gauge, so that was that minimum requirement of 4 gauge. It said cable tray is complying with 392.60b, and that's what we looked up earlier, and we saw that meant that it was actually identified as a equipment grounding conductor, whether it's through bolting connections and 250.96 processes, or whether it had bonding jumpers. Saying that it complies, it says metal raceways in accordance with 250.118 or auxiliary gutters shall be permitted as the equipment grounding conductor. So all this is reiterating that, you know what, yes, you can use a raceway if it's in there, or yes, you can use a cable tray if it qualifies. Okay, so again, perfectly fine there. And that would allow people to be able to run a multi-conductor cable like a tray cable that might not necessarily have an equipment grounding conductor in it, which ultimately lowers the cost of their tray cable. Because you can get it with or without an equipment grounding conductor, but you still got to have an equipment grounding conductor. So if you're utilizing this rule, then you're able to use that specialized tray cable that might not have an equipment grounding in it. Okay, I'm an advocate for all cable assemblies to have an equipment grounding conductor in it based on standards and whatnot, but there is the way this is written, it does allow you to utilize that product, but you better know that gutter or that raceway or that tray qualifies. That's all I'm saying. All right, then you get to D, and D says, now, except as provided in 250.122 F2B, okay, it says, for raceways or cable tray installations, the equipment grounding conductor in each multi-conductor cable shall be sized in accordance with 250.122 based on the overcurrent protective device for the feeder or branch circuit. Okay, so it says, except for as provided in 250.122 F2. So really what that's saying is that we're giving you allowance to say, okay, your overcurrent device, because you're running them in parallel, is those equipment grounding conductors and those cables are going to be undersized based on the fact that you're doing it in parallel. But since you're running a single equipment grounding conductor and you're meeting the requirements of 250.122 F2B, we'll let you do that, okay? So that was the real significance of that change. But then it's reminding you at D saying, oh, but by the way, if you're not going to use B and you're going to put cables, multi-conductor cables in these raceways or cable trays, just remember that the equipment grounding conductor in those multi-conductor cables has to be sized in accordance to 250.122, and it is based on the overcurrent protected device for that feeder or branch circuit, whatever that cable is being used for. Okay, so that could mean that if I don't want to use the option of 250.122 F2B and run the single, then I have to ultimately get equipment grounding conductors sized larger in my cable assembly with the intent for them to be done in parallel. And that is going to be a special order. That's not an off-the-shelf thing. We don't know when you buy an MC cable how many sets you're going to run or what overcurrent device you're going to parallel these things up to. So we have to make it. And, of course, you're going to pay more. So this was an effort to try to help the industry and give them an option to be able to use off-the-shelf cable assemblies. But by allowing this and allowing the option for that single equipment grounding conductor in conjunction with those undersized equipment grounding conductors in cable assemblies when ran in parallel, that created the argument where people said, well, wait a minute, we'll let you do it here, then why don't you let me parallel my equipment grounding conductors? And I understand that they got to be at least 1 aught larger. I follow all the rules of paralleling. I'm willing to follow it, but I don't want to run a full-size equipment in every raceway. Well, then that's when we needed research and to be done. And I don't know that any was actually submitted for the allowance in 250.122 F2. I'm not sure there was any research there. I don't really know. I don't remember. I kind of came in the middle of last cycle 5, so I really don't remember the argument. I think that was already, that ship had sailed. Otherwise, I wouldn't have thought much about it, to be honest with you. But it was there and it got in there, and I'm sure there's justification. You can go back and look at the public inputs and see how it got in there and everything like that. And in plausibility, the question came up is, how does that fault current in that cable assembly divide out? And that same argument rings true for the concept of this new proposed table for the 2020. And so it makes you think about all these things. And I'm sure there are people out there that are much smarter than me that sit on that panel that are looking at all these things or getting together collectively trying to figure out how do we do this. But the whole effort here was to allow electricians, for example, to be able to run parallels. And I don't hear of things burning up. I don't hear of problems. But I also don't know how many people are actually using this rule and running the cables in parallel and then running a single equipment grounding conductor and then connecting them together at each end, creating a kind of a parallel effect. I don't know. I don't know how many people are actually doing it to get any feedback from that. But that's certainly going to come up in the argument on, it's okay here, why won't you let me parallel here? You see what I'm saying? And then the other argument again is, well, even if I do run all these equipment grounding conductors and I am able to parallel it, collectively the circular mill is going to be much larger than what we required in each individual raceway. But, the arguments would probably go on all day long. I think research needs to be done. At this point, I don't know if we're ready for it yet, unless somebody comes to the table, because people have brought up concerns. And the ones that concern us the most really is the overcurrent device manufacturers. If they're worried about it clearing their breaker, then we should be worried. So once we get the green light from them, then maybe this all makes sense. I think that they're looking at it. In fact, I know they're looking at it. Okay, we'll see what comes out of that. Lastly, in 250.122, we'll talk about G. It says feeder taps. It says equipment grounded conductors run with feeder taps. Okay, so if I have a feeder and I'm going to tap it and I'm going to run the equipment grounded conductor, I have to carry on that equipment grounded conductor. Obviously, it's not going to end there at the feeder tap. It says the equipment grounded conductor run with feeder taps shall not be smaller than shown in table 250.122 based on the rating of the overcurrent device ahead of the feeder, but shall not be required to be larger than the tap conductors. Okay, so you're going to base it on whatever the overcurrent device is protecting the feeder, and then you're going to look at the conductors that are being tapped from it, and you base it on the feeder's device, but at the end of the day, that doesn't have to be larger than the tap conductors itself. Okay, so that's just kind of giving you some rules. If I'm tapping with 10 gauge for some reason from a feeder, and all the rules, the tap rules in 240.21 permit me to do this, and I do that, and those are 10 gauge conductors, then I wouldn't necessarily need to have an equipment grounded conductor that's larger than that 10. Okay, that's basically what it's saying. Now, of course, lastly, I guess we look at the table and understand that table 250.122 is a minimum size. Okay, so it does have a note at the bottom which says, you know what, if you have to comply with 250.4A5 or B4, that equipment grounded conductor shall be sized larger than is given in this table. Okay, so this is a minimum. Engineers can specify the need for it to be larger. If that's what they've done, they're the ones that are putting their stamp on it. They're the ones I'm going to listen to, okay? Even if I disagree, whatever, you got to know they're the ones designing the system. They're the ones that are designing the overcurrent devices. They're the ones that might have looked at this table, and then instead they went to the actual short circuit current that's going to be available. They went to the ICEA tables. They went to the characteristics that are in the publication P32382, which is the short circuit characteristics of cable tables. Maybe they did all this. And they looked at it and said, no. I want that equipment grounded conductor to be larger. Well, you know what? They're the engineer, my friend. You could be an electrician. I teach a lot of engineers. But I can tell you, if they put their time in, they've usually worked with the curves. They've usually worked with the circuit breaker manufacturers. And those are some intensely intelligent individuals, the manufacturers of circuit breakers and the engineers behind those. I'm not talking about application engineers. I'm talking about the engineers that are part of the design process that you talk to when you call the company directly, right? Eaton, Cutler Hammer, Square D, there's also Schneider's, which is same as Square D. Siemens, all of those individuals that are in their technical division are immensely intelligent individuals. And they work with it. And if they're working with the engineer and they supply the data, then if that's what the engineer specifies and it's larger than what's in this table, then I'm going to go with what they say. I'm not going to argue with them, okay? If I'm designing it and I don't know anything else, I'm going to go with the minimum size that's given here, okay? And so, again, as you see, this goes down to 6,000 amps. And when it goes to 6,000 amps, it's 800. Or aluminum, it's 1,200, okay? So, table is what it is and how you're running it, okay? Other than that, I think that's it. Oh, I will tell you one thing. A lot of people also ask them, you know where it shows here on the table that says 60 amperes and it says a 10 gauge in copper and an 8 gauge in aluminum, and then it jumps all the way to 100? Anything that's over 60, you're going to use the 100 value. Anything that's over 100, you're going to use the 200 value here. So that's how it jumps as you go down the table. Okay, so anything that falls between, let's say, the 100 and 200, you're going to use the size for a 200. Anything that falls between the 200 and 300, you're going to use the size for the 300. Okay, that's how the table works, and you're going to do it that way. All right, guys, that's all I'm going to cover in 250.122. I kind of gave you some insight of where we're going. I can't give you a whole lot because I've kind of stayed remote from the process. Once I knew they formed a task group and they're trying to look at all the issues, I do know that motors and instantaneous trip aspects and all that kind of threw a wrinkle in the table's concept. Also, what is different is that in this they also added the application once you got over 6,000 amps applications, for example, overcurrent devices, we threw in the 12.5% to account for increased sizing based on the sizes that were in that table. And so we'll just have to see how it fleshes out. But I just want to give you a little taste I encourage you, if any of them you're waiting to find the outcome, that's a pretty neat one for you to keep track of and see where it's going to go. I'm sure it's going to be a pretty good one. So I'm looking forward to that. I'm certainly looking more forward to Code Banking Panel 5's couple days than I am Code Panel 17. It's too many chest pounding in 17. I love the intelligence of Code Panel 5. There's intelligent people in 17 too, don't get me wrong, but it's too much bravado there, man. 5 is a neat one, because so if you ever get a chance to go to Code Making Panels, be sure to come into Code Making Panel 5. Immensely intelligent individuals in there, and what they're contemplating, what we're talking about. We're saving lives in there. We are in 17 as well, but again, it just ends up being, I don't know. I love doing it, right? I love being a part of it, but, Code Making Panel 5 is really where my heart really is. But anyway, enough of that. I'm dedicated to both of them and trying to make the code better, as everybody else is. Again, I have no, especially when I'm going into this public comment stage, I have no agendas. I have nothing that I'm waving my flag up for. I had a bunch of people that gave me a bunch of grief about the PVC jacket at MC. It was successful until it went to vote, and then it failed by one vote. Kind of steered in the wrong direction because of personalities on that committee, not for fact, because I certainly showed all the facts there. But anyway, I'm over it. I'm moving on. I'll let them just struggle with the fact that none of the wiring methods that are allowed for pools today are actually UL listed for use in those environments. So I'll let us keep putting these wiring methods in there that have had no data or research done to them. We'll just keep using them and hope they don't fail over time. Anyway, that's it. Enough of my get off of my little stool there. God bless till next time, folks. Hope you got something out of this 250.122. If you want more videos or more podcasts on grounding and bonding, just let me know. I love talking about grounding and bonding. It's probably one of my favorite topics ever. So until next time, stay safe and God bless, folks.
Every day, the future's getting closer. Every day, the future's looking bright. Every day is another beginning.